All right, ladies and gentlemen, let's get started with part 2 with graphing piecewise functions. So there are several ways, as we talked about, to graph piecewise functions. The first method is to use the slope and y-intercept. The second method is to... the second way is to graph it using a table of values. So the first way, let's talk about how we do it with slope and y-intercept. For this equation, we have negative 2x plus 3 and 3x minus 2. Those are the two equations we're going to graph. So let's start by graphing the negative 2x plus 3. So negative 2x plus 3 has a y-intercept at 3. So I'm going to put a point at the y-intercept of 3, which is right here. From that point, my slope is negative 2. So I'm going to go down 2 to the right 1 and put a point. I can continue that this way. But one thing you need to remember is where your boundary line is. And in this case, your boundary line is at x equals 1. So when I graph this, I need to remember that I'm not going to actually go past that line for either of the functions. Okay? So in this function, I want everything less than 1. So this line is going to cross this line, the boundary line, right here. And since it's just less than, it's going to be an open circle. And then I want everything to the left because it's less than. The second equation is 3x minus 2. So my y-intercept is at negative 2, so I'm going to go down 2 on the y-axis, put a point. And then my slope is 3, so I'm going to go up 3 over 1, put a point. And then again, you notice I run into my boundary line. Let's just keep going. Up 3 over 1. And you'll notice that I want everything to the right because it's greater than, pointing to the right. Which means I really just want everything up here to the right of that boundary line. So those points there on the bottom were just to help me kind of graph the other two equations. And now you're done. Okay, table of values, I could have set up a table of values for each of these functions. So I could have done xy for the first one, xy for this one, and then chosen values for this one that were less than 1, chosen values for one that were greater, or values for x that are greater than 1, and then graph them like that as well. And that's actually going to be the easiest thing to do for number 14. Okay, so for number 14, I have one function of x plus 3, but I only want the x values between negative 2 and 1. So a table of values for this is probably going to be the easiest thing to do. So I'm going to set up a table xy. I'm going to start at negative 2, negative 1, 0, and 1, and I'm going to stop there. Now notice for negative 2, it's less than or equal to, so that's going to be a closed circle. 1 is just less than, so therefore it's going to be an open circle, and I'm going to connect them in between. So that's what my piece of line is going to look like on the graph. So let's go ahead and graph those coordinates after I evaluate them. So you could also go to your graphing calculator, and you could bring up your graphing calculator, and notice that when you do that, it will give you the table of values for each function. So if you want to go to y equals and plug in the equation for the function, so go to y equals, and you can plug in x plus 3. This is why a graphing calculator is a good thing to have. Press second graph. Again, you can see those tables of value. So at negative 2, the function is equal to 1. So you have 1, 2, 3, 4. Okay, or 1, actually, it's going to be 1, 0, it's going to go down. So 1, 0, negative 1, and negative 2. So at negative 2, 1, is that right? Let me just double check that. Go up here. Yeah. So when x is negative 2, oh wait, I went the wrong way. Sorry. I was going the right way. Let me erase those. I made a mistake. That's okay. We can very quickly correct that mistake. There we go. Alright, so looking at your values, when x is negative 2, it's 1. When x is negative 1, it's 2. So I count up. 1, 2, 3, 4. So at negative 2, 1, I have a closed circle. as I indicated here. At negative 1, 2, I have another closed circle. 0, 3, and 1, 4, I actually have an open circle, and then I connect all of those. So that's the one piece. Then, when x is 1, what's y? Negative 5. So 1 over 1 down 5, 1, 2, 3, 4, 5, put a point. And that's all that function is. It's just a single point. Notice I don't have an interval here. Then for the last one, again, I'm going to make a table, x and y. I'm going to go with values from 1 to 4. So 1, 2, 3, 4. Again, I can go to my calculator, and I can plug in the function of negative x plus 2. Press your graph key, you could see it. You really don't need to see it. You more just need the table of values. So second graph, go to 1. When x is 1, y is 1, 1, 0, negative 1, negative 2. So 1, 1, 0, negative 1, negative 2. Okay? So you can see that that matches here. And now, again, you're going to decide open or closed circles. So at the x value of 1, it's going to be an open circle. And the x value of 4, it's going to be a closed circle. And you're going to connect them. So 1, 1 is going to be an open circle. 2, 0 is going to be closed, 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 and connect them. So there's your 3 pieces of graph for this function. So let's look at number 15 together. Number 15, I have my boundary line at 0. So I can just go ahead and draw that boundary line in. Or I can do a table of values. That's okay as well. Okay, either one. But again, this is going to be your boundary line right on the y-axis. Okay. This one is actually probably easier to graph using slope and y-intercept because my boundary is at 0. You could do a table of values, but notice for any x value, it's always going to be negative 4 because this is a horizontal line. So my y-intercept is at negative 4. So I got a 1, 2, 3, 4. It's going to be an open circle because it's just less than 0. Less than means I want everything to the left. So it's really just going to be a horizontal line to the left. Half x has a y-intercept at 0 as well, but this time I want to include 0. So on my y-axis, I'm going to put a solid dot. And then I'm going to go up 1 over 2. Up 1 over 2. And I want everything greater than. Okay? And you're done. Now you could verify that with tables of values. If you wanted to do the tables of values, that's fine as well. Or you can just use the slope and y-intercept. Okay? Next one, I have 2 pieces. When 3x, it's going to be the equation of 3x except at what value? 0. So I'm going to include all values except 0. So I'm going to graph the equation 3x, which means my y-intercept is 0. I go up 3 over 1, or down 3 over 1, and then draw my line. My line's going to look something like this. Okay? Now, I want all values except when x is 0, which is right here. So I'm actually going to erase where x is 0. And when x is 0, it's actually going to have a hole in the graph, that open circle, because I don't want to include 0. But when x is 0, what's the value of y? 4. 0, 4. So go over 0, up 4, and you just have a single point up here on the y-axis. So you have a hole in your graph on that equation, but then you have it filled in up here at the top. Okay, so for number 17, this one would probably be best to do using a table of values because I have 3 different intervals. So again, using a table of values for this one is probably going to be the most efficient way to graph this one. So I have x plus 4 if x is less than negative 2. So negative 2, and what are numbers less than negative 2? Negative 3, negative 4. Negative 2 is going to be an open circle, and then it's going to be everything. Do I keep going, or does it stop at negative 4? What does it do? Does it stop at negative 4? No, it keeps going, so I have an arrow. So now I'm going to see what the value of the function is when I plug in each of these. So again, go to your y equals, and you're going to put in x plus 4. And really all you need to see is the table. So when x is negative 2, y is 2, 1, and 0. So 2, 1, and 0. So negative 2, 2 is going to be an open circle. Negative 3, 1 is going to be a closed circle, and negative 4, 0 is going to be a closed circle, and then it's going to keep going, just like it was up here in the table. Next part, another table, x, y. This time I only want from negative 2 to 2. So negative 2, negative 1, 0, 1, and 2. Now for this function, no matter what the value of x is, it's always going to be 3. So 3, 3, 3, 3, 3. And if you want to see that, what it looks like graphically, if I go to y equals and I plug in y equals 3, and then look at my table of values, you'll notice, look, y is always 3 no matter what x is. So I can keep going with this because it's a horizontal line. So now when I graph this, negative 2 is going to be a closed circle, but 2 is going to be an open circle. And then I connect them in between. So negative 2, 3. Negative 1, 3. 3. I keep going all the way up to 2, where 2 is an open circle, and then I connect all those values. And then for my last piece, again, x and y, I start at 2, and I go everything greater, so that's 2, 3, 4. Again, 2 is a closed circle because it's greater than, and I don't stop at 4. I can keep going down, right? So it's going to be in line with an arrow. So again, I can go and I can plug these values in. It's easiest just to do it this way. You can do x plus 2. Do second graph to look at your table of values. And when x is 2, y is 4, 5, and 6. So I put in a 4, a 5, and a 6. So at 2, 4, I have a closed circle. At 3, 5, closed. At 4, 6, closed. And then I keep going with it. So there's your piecewise function. This last one is our step function. Because if I put in all of these and I look at them as far as what they look like on my calculator, if I put in a negative 4 here, y equals negative 4, notice it's just a horizontal line. But what piece of that horizontal line do I want? I want it between negative 3 and negative 1. And then for negative 2, what piece do I want of that horizontal line, negative 2? Well, I want it between negative 1 and 1. So what you can do is you can go ahead and graph each of those lines. So you can graph. Okay, so we're going to first graph the line of negative 4, which is here. Then negative 2. Then 0. And then 2. So those are all the horizontal lines represented by these numbers. Now, I can just select which pieces I want. So for this bottom line, I only want from negative 3, well, negative 3 is here, to negative 1. I want to include negative 3, but I don't want to include negative 1, so it's only that piece. For the next one, I want to start at negative 1 and go to positive 1. Sorry, I'm going to start with a solid to an open and connect them. Then at 0, I'm going to start at 1 and go to 3, open. And then for 2, I'm going to start at 3 and go to 5, open. So you're just going to get these black pieces of the graph when you're done. And you can then erase those lines that you originally had. Okay? now we're going to start with writing a piecewise function from a graph. And with all of these, you do need to identify the slope and y-intercept of each piece. And then you also have to identify the interval for each piece. So as you can see on this first graph, my y-intercept of this first piece is going to be at -1. So I'm going to put a y-intercept of -1. Then my slope is up 1 to the left, 1, 2, 3. Let's see, 1, 2, 3. So my slope is 1 over -3, which is basically just -1/3. For the other piece over here, my slope is up 1 over 1, and it has the same y-intercept right here at -1. So now I'm going to write my equations for each of these. My equations for this piece is going to be -1/3 x plus 1. My equation for this is going to be 1x, or just x minus 1. Oops, that should be plus a -1. So that you can either do plus -1 or just -1. And that's if, now you're going to write your intervals. This line is everything that is to the left, which is less than or equal to 0, because your boundary line, remember you have to identify where that boundary line is. So your boundary line is right here, which is where each piece is separated. So that's just going to be 0. And then the other piece is to the right, which is greater than or equal to 0. Repeat the process. Slope and y-intercept. The slope of that first line and the y-intercept. Well, the slope is down 1 to the left 1, or I could go from left to right is up 1 over 1. So that's a positive slope because it goes up from left to right. So my slope is 1, my y-intercept is 0. Over here, my slope is 0 because it's a horizontal line, and my y-intercept is at 2. So now I'm going to write the equations. mx plus b, 1x plus 0 or just x. And then again you want to identify your boundary line. So your boundary line is again at 0. So that's if x is to the left of 0 or x is less than or equal to 0 because it's a solid dot. This is going to be an open dot. So it's going to be, my equation is going to be 0x plus 2 or just 2 if x is greater than 0. So again, this value here comes from wherever your boundary line is that separates the two pieces. Questions?